So what are we going to get as product? There are two reactions.
Sir, second one, sir.
Second one, yeah, half of the answer you have given correctly. Half of the problem is correctly solved, but you need to solve the another half of the problem to get the right answer. You are very close to the right answer, right? Okay. Yeah. What you missed, just half of the problem you solved it correctly. Just half of it you missed. So that also you can solve it correctly. Yeah. So what other reagent is given in the question?
Sir, hydrogen, palladium, and carbon.
So what it is, what that reagent is going to do? Yeah, tell me. Hydrogen, palladium, and carbon. Right? What it gives. Yeah. Yeah, Navi. I didn't get. It is going to do what? Yeah. It is catalytic hydrogenation reaction, right? So you get
Yes,
the
sir.
double bond. You got option 2. Okay. But the final answer is going to be option 3. Why?
Because of hydrogen being added.
Yeah, hydrogen being added. Yeah, exactly. Okay. So that's how you are going to do it, right? Now the next thing is what other nucleophilic addition you are aware of on aldehydes and ketones? Any other nucleophilic addition reaction?
No, sir. Last one.
Yeah, addition of NHSO3. So what you are going to get? What this product is known as? Yeah, it is known
How
as
is it?
sodium bisulfite adduct. Yeah,
Sir, how is it bisulfite? There's only one sulfur.
it is
There's only one sulfur, right? Sir, how is it bisulfite?
one.
One sulfur atom was in the reaction, right,
Yeah,
sir?
bisulfite. Bisulfite is actually hydrogen sulfide. It is the addition of hydrogen sulfide, like bicarbonate. Bicarbonate is NHCO3.
Yes, sir.
Okay, so it is formed by addition of bisulfite, right? Clear?
Yes, sir.
So hydrogen sulfide is known as bisulfite, right?
Yes, sir.
So it is white crystalline solid. And there is a carbon sulfur bond formation. Okay, clear?
Yes, sir.
It happens, and this can be used. Aldehyde give this test actually, and the small ketones can react easily. The larger ketone will not react due to steric hindrance. Okay, and it can be used to separate them. So if you have this bisulfite, it can be filtered because it is crystalline solid. So it can be filtered out, right? And you can get the product. Okay, right?
Yes, sir.
So these are some common nucleophilic addition reactions on aldehydes and ketones. The other reactions, aldehyde ketones, are aldol condensation, aldol family reactions. So what are aldol family reactions? Any idea?
Sir, they are called as the reaction between an aldehyde or a ketone and
Yeah,
base, I think, to form a alpha beta and saturated
yeah,
compound.
yeah, exactly. So which type of aldehydes give this test?
So I think so. So primary
Which
aldehydes.
type of aldehyde give this reaction? Okay, actually the aldehyde which contain at least one alpha hydrogen. What is alpha hydrogen?
hydrogen attached to carbon adjacent to the aldehyde carbon.
Yeah.
So this means that there should be at least 2 carbon atoms.
Yeah, there should be at least 2 carbon. And this is the alpha carbon and this is the alpha hydrogen. So aldehydes and ketones should have at least 1 alpha hydrogen. Then only they are going to give this test. Okay. Reaction. So in the presence of base, so which of the following aldehyde and ketone give aldol condensation? Right?
Yes, sir.
So formaldehyde, benzaldehyde, benzophenone, and acetophenone.
So acetophenone means it will be like
It will be, and these are common names, and the common names actually they're very common. So you need to learn them, very important. Okay.
yes, sir. Formaldehyde, benzaldehyde, benzophenone. Yes, sir. It's the acetophenone.
Benzophenone and acetophenone. So which of the following is going to give aldol condensation?
Sir, will it be
No, it is going to be
no,
acetophenone.
acetophenone.
Right?
Yes, sir.
So this is HCHO. It doesn't have alpha carbon. Okay. And benzaldehyde, does it have alpha carbon? Tell me. Benzaldehyde,
Yes, sir.
does it have alpha carbon? For benzaldehyde, alpha carbon is there, but
Yes,
alpha
sir.
hydrogen is not there.
Yes, sir.
Right? You have benzene, you have C double bond OH. So this is the alpha carbon, but there is no hydrogen. No possibility of hydrogen because already it is making 4 bonds. Okay. And benzophenone. What about benzophenone? What is benzophenone? Tell me.
Sir, but benzaldehyde, there is a possibility, right?
No, there is no possibility. Actually, it gives some other reaction which is known as Kennesaw, which doesn't need any alpha hydrogen. Okay.
Yes, sir. Yes, sir.
Benzophenone, what about benzophenone?
No alpha hydrogen.
Yeah. So you are in which school right now? You are in Riyadh now?
Sir, the mom, sir.
Hmm?
The mom.
Okay. So and your center is going to become come there only, or you're going to come to India?
I think the mom only, sir.
Okay. So which is going to give? Tell me.
Sir?
Yeah, now you can understand acetophenone, why it is going to give you aldol condensation.
Yes,
Clear?
sir. Yes, sir.
This is the alpha carbon and alpha hydrogen. Both are present. Okay, so first category questions is this only. So you need to be very careful to decide whether it is going to give aldol or not. Okay, very important questions. If the structure is written, then it is not a problem. But what they will do, they will not give you the structure, they will give you some common names. Because some common names are very common and they expect from you to know the common names. Okay, so that's why they give you common names, right?
Yes, sir.
So this I hope is clear. So for example, if you have or if you have cyclohexanone or which one is going to give aldol condensation?
Sir, B.
D is going to give aldol condensation. Exactly. So this is not going to give, this is not going to give, this also is not going to give because it is doubly bonded carbon. So hydrogen will not be removed from this, right? Hydrogens are there, but they are not acidic, right?
What, sir?
Their
Last one.
hydrogens are there, but they are not acidic hydrogen, right? So they will not be removed.
Yes, sir.
Clear? So
Yes, sir.
only B option is going to give you the aldol condensation. Now the next thing is how it happens, why, what is the mechanism? You need to know
Sir,
little bit of mechanism to solve some problems. Yeah,
could you just show the above question, sir? Just a minute.
yeah.
Just copy. Sir, for aldol condensation, the hydrogens should be acidic hydrogen
Yeah. So why alpha hydrogen is acidic in nature?
because it can easily detach.
Yeah, it can be easily detached. So mechanism. So before writing the mechanism, I will write one question of aldol condensation. Some basic question, most elementary question. So here we are going to take the two molecules of aldehyde. Okay, and with NaOH. And what you are going to do? You are going to combine them, sir. And if no heat is given, You are going to make the double bond O as OH. And you are going to connect the alpha carbon with the CO. Is it clear? If there is no heat, okay,
Yes, sir.
and so if there is no heat, you are going to make beta hydroxyaldehyde or ketone, right?
Yes, sir.
What this beta hydroxyaldehyde and ketone known as, what's the common name for this?
Aldol or
Yeah, this is aldol because there is an aldehyde and there is an alcohol. Okay, and because of the name is given aldol condensation, right?
yes, sir.
So this is, but if heat is there, what you are going to do? You are going to remove water. Okay. Why the water is removed? Tell me.
Dehydration, sir, because of
Yeah,
heating.
and there is a double bond which is found adjacent to a double bond, and because of the resonance, this is stable, right? And this is known as alpha beta unsaturated aldehyde or a ketone. And if heat is given, you will directly come to this point. And if heat is not given, you will make that beta hydroxy compound. Okay.
Yes, sir. And this one is called, sir?
This is alpha beta unsaturated aldehyde or
No, sir.
ketone.
Last one was called as aldol or ketol. Sir. This one is no special name.
No, this is alpha, just the common name, alpha beta, no specific name.
Yes, sir.
Okay. So what happens over here is, this is, if directly heat is given, you will come down to this. But you are removing active hydrogen, okay? You are removing the alpha hydrogen. So that's why the alpha hydrogen is required. Okay. Without alpha hydrogen, this is not going to happen. And what's the mechanism for it? How it happens? You need to know the mechanism also. So you have taken a base. This happens in the presence of dilute base. And what a base will do? Yeah, tell me.
It will polarize it.
Yeah, base actually will remove the acidic hydrogen. It will break away the acidic hydrogen. Right?
Sir, one question, sir. In the
Yeah,
final product, whatever we get, it will be alpha beta unsaturated aldehyde or ketone also will come, sir.
it depends actually what you have taken. If you have taken aldehyde, it will be aldehyde. If ketone, ketone. But normally ketones are less reactive towards aldol. They also give, but aldehydes are more common, right?
Yes, sir.
So now minus will form. Okay, why this minus has formed? This minus can undergo resonance also. This is the resonance structure, right? And but this is not the final answer, because this minus is going to get neutralized by attaching itself to someone, and that someone is none other than the original molecule. Yeah. Okay, original compound, another molecule of the original compound which you are from which you have started reaction. Is it clear?
Yes, sir.
So this carbanion is going to do the nucleophilic addition reaction on the CO, and that's how you are going to. This is minus CH2C. So it is known as, and this minus is, look here, the base has started this reaction. Can you see over here? The base has started the reaction by removing acidic hydrogen from aldehyde. Okay.
Yes, sir.
And it formed water. And now this O minus will again, it is now, this O minus is a base, so it will again accept its H plus and is going to give you CH3, CHOH, CH2. Plus OH minus is regenerated. So base has helped the reaction to happen. That's why it is known as base catalyzed reaction. Okay, base catalyzed aldol.
Sir, so base is a catalyst in this reaction.
Yeah, it is a catalyst. It is forming again, right?
Yes, sir.
So catalyst is not consumed in the reaction. It is formed back. And if you take the heat, the water will be removed. And you will end up with alpha beta unsaturated compound. This is the final answer if heat is given, but otherwise if heat is not given, then you will use only the upper one as the right answer. Okay.
Yes, sir.
So now, yeah. So this is the most common question which are asked in every examination. So let's do some practice. So what is the structure of A and B?
Sir, could you just show the mechanism? Just copy it.
Yeah. So that was the reaction. Okay.
Yes, sir.
This was the overall reaction.
Overall reaction I've written, sir. Just
Yeah.
the
And the mechanism starts with the removal of H plus from alpha hydrogen, and the carbon that is known as enolate ion. This one. Okay. And the carbon ion from this lead to the formation of a carbon ion.
what is that called, sir? Inolic ion.
Enolate. Not very common, not much required, but you need to understand the mechanism. So
Sir,
this
the
minus,
resonance
yeah,
is called
this, yeah, and that minus C minus actually is going to come and attack on the other molecule of the same type. And the two molecules are going to join together, right?
yes, sir.
And now the HO minus will accept H plus from the base, from the water to regenerate the base. So base is not consumed, it has just helped the reaction to happen. And so that's why it is called base catalyzed. And you got alpha beta alpha, you got beta hydroxy aldehyde or a ketone. Okay. If heat is not given, you are going to stop here, right? But if heat is given, or if there is a phenyl group, listen very carefully, then you are going to remove water and you are going to make that double bond. Even with the phenyl, right?
Sir, so if phenol group is present, we need to require, we need to apply heat.
Pardon?
1 minute, sir.
Hmm. Yeah. So if phenyl is there, then
Sir, so if the phenol group is present, this
yeah,
reaction of base will give alpha beta hydroxy.
yeah, phenyl group also makes the double bond very stable. That's why, right? So that's
Yes, sir.
why you are going to get the double bond as the final product.
I finished writing it, sir.
Right. So what are A and B? So first reaction is ozonolysis, and ozonolysis actually is very commonly asked with your aldol condensation. You can see a lot of question. In which the ozonolysis is followed by, because ozonolysis is going to give you aldehyde and ketone. That is why.
Yes, sir.
So tell me, what are A and B?
So, how does ozonolysis occur?
Yeah,
So, how does ozonolysis occur?
actually, ozonolysis, the shortcut is you can break the double bond and put oxygen on both the sides of the double bond. Okay, if it is reductive ozonolysis. Okay, but if it is oxidative ozonolysis in which the hydrogen peroxide is given, reductive is zinc and dimethyl sulfide. If it is there, just break the double bond, put oxygen on both the side, and you will get aldehyde or ketone. But in oxidative ozonolysis, aldehyde you will change it to carboxylic acid. That's it. Okay.
Sir, in oxidative, what will be given, sir, along with O3?
In oxidative ozonolysis, if some of the molecule are forming aldehyde, they only get affected in the oxidative ozonolysis. They form carboxylic acid, right? For example, if you have CHCS3, okay. So if you take O3 zinc or dimethyl sulfide, this is reductive ozonolysis, and you are going to break only the double bond and put oxygen. Both, this is ketone and aldehyde you have. Understood? But
Yes,
if
sir.
it is oxidative, then you have to be careful, and just little bit care you need to take. Actually, you need to see what is given in the under the ozone. If zinc is not, if water is given, then also it is oxidative. Okay, so this was ketone, so this is not going, so cut the double bond, put oxygen, so this ketone is not going to change. But on the right hand side you were having aldehyde, so aldehyde actually get oxidized very easily and you will end up with carboxylic acid in this case. Okay, so oxidative ozonolysis affects only the aldehyde portions. They are going to get changed to carboxylic acid, right?
Yes, sir.
Okay, so let's do the above question. So A and B. A is very simple. Okay,
Sir,
but if they,
cyclohexanone.
cyclohexanone, right? And what is B? Now this is a ketone, you need to do the aldol condensation. And heat is there. Right?
Yes, sir. Sir, is there a method like technique to do aldol condensation?
Yeah, just quickly you can do. What you can do is you can select the alpha hydrogen and you can select the doubly bonded oxygen. Okay. Select the alpha hydrogen and doubly bonded oxygen and remove water if it is given. And you are going to get the answer very quickly. Right? So what I will do,
Yes, sir.
I will show it here. So I will write the ketone over here, right? And I will write the same ketone. Can you see that this ketone is same? But what I will do, I will show the hydrogen and I will remove the water. Alpha hydrogen, right?
Yes, sir.
So what is going to be the structure of B? Right? Clear?
Yes, sir.
Okay, now you have crossed aldol. What do you mean by crossed aldol?
So can you show the final structure over there?
Yeah, yes.
Yes, sir.
So in your CBSE, what all chapters covered?
We have finished chemical kinetics. We're doing electrochemistry now.
Okay. Good. So crossed aldol. What do you understand by cross reaction?
This last reaction we have seen like the same aldehyde or ketone undergoing aldol condensation, but here you choose different aldehydes or ketones.
Yeah, different aldehyde, two different aldehyde. Okay. So how many product you can expect if you do the crossed aldol of acetaldehyde and propanol?
So four.
Yeah, four different products. Right?
Yes, sir.
So four different products we are going to get. And this is also crossed aldol. If you take a benzaldehyde and acetaldehyde, what you are going to get? How many products you are going to get with NaOH and heat?
4 products, sir.
No, here you are not going to get the 4 products. Only 2. Why?
So self-aldol will not take place.
Not self-aldol. Actually, this doesn't have any alpha hydrogen. So this will cut down that. This will cut down to 2 products, right?
Yes, sir.
Yes. So you are going to get only. So what I will do, this can offer only its double bond O, but it can't offer its alpha hydrogens, right? And this can offer its alpha hydrogen as well. Both it can alpha hydrogen as well as the double bond O. Okay. So tell me what are the products, how you are going to make it. Have you understood how I have written these?
Yes, sir.
So in real terms, which is the cross product? Yeah. Tell me, who is actually the cross product? The upper one or the lower one or both?
So the upper one is a cross
Yeah,
product.
upper one is the cross product and the lower one is a self product. But you can't prevent the self product also being formed. What you can do is you can take this in excess. So then this is the major product. Or if nothing is given, you are going to make the cross product, right? But if they ask you the total products, you are going to write the crossed as well as self, right?
Yes, sir.
Okay. So this you understood, right? Okay. So if they give you what is the answer, if they ask you just one correct option, PHCH double bond CHCHO. This is going to be the answer. This is the cross product. And now let's do some more problems. related to aldol condensation. And what is intramolecular aldol? So in crossed aldol condensation, actually one of the aldehyde should not contain alpha hydrogen, right? And if any one of the aldehyde contain alpha hydrogen, then you will have aldol taking place. And this is without what? This is without heat. So what is going to be the answer? Yeah, Nabil.
Sir, we will get 3 moles of CH2 double bond CH2
No,
for
without
I
heat.
think
Without heat.
without heat. Then
Yeah. Heat is not given. So first try it with 1 mole. Then 1 mole of acetaldehyde and 1 mole of formaldehyde.
1 mole of acetaldehyde.
Yeah, and 1 mole of formaldehyde. So think little bit of the mechanism. Alpha hydrogen, this is only having the alpha hydrogen, not that one. Write it like this. Remove the alpha hydrogen from the carbon, make a carbon ion, join it to C double bond O, and put the alpha hydrogen on the O minus. Right?
Yes, sir.
So with 1 mole, what you are going to get? Okay.
Sir, can you say again how this happens?
Pardon?
Sir, can you say again how this happens?
This alpha hydrogen will be removed. Minus will come and join on the CO, right? Clear? O
Yes,
minus
sir.
will form and it will change to OH, right?
Yes, sir.
But this is going to happen 3 times total. Why 3 times?
Because 3 moles of
Yeah,
formaldehyde.
3. Yeah. So you have 2 moles is still left. 1 mole is joined, 2 mole left, and there are 2 alpha hydrogen. So remove this alpha hydrogen also. Remove this hydrogen also. So remember, in organic, actually, wherever you have formaldehyde, that formaldehyde get attached to CH2H. Right?
Yes, sir.
So you are going to get. So we are going to do one more time, but that is going to be a different reaction. So we will discuss it later. Okay. So, but remember that this is a very important question.
Sir, this is after using 2 moles, right, sir? Third mole of that.
No. So for 3 moles, 3 times.
Yes.
Okay. Clear?
Yes, sir.
And what is intramolecular aldol? It is also same, but the slightly name is different. Yeah. Intra means what? Within the same molecule. So suppose if you have two aldehydes within the same molecule, then you are going to have intramolecular aldol condensation, right?
Yes, sir.
So you are going to do, it is not a new reaction, that's the same reaction, but you are going to do within the same molecule and it will form a cyclic product. Because the molecules, the same molecule has having two sides aldehyde, so those two aldehyde are going to join internally, right? So cyclization is going to happen in intramolecular. Okay, but this is asked many times, but it is, but you should be careful while making the ring, and it is often asked with ozonolysis. So what is the structure of B? Yeah. So the problem here is that many students first time they can make mistake. What's going to be the answer? Yeah, Nabil.
Sir, how ozone analysis will take place here?
Same. There is a double bond you can see. Okay. Cut that double bond. Put oxygen, oxygen.
Sir, they need have two aldehyde groups.
Yeah, two aldehyde groups, right? And can these aldehyde group give you aldol condensation?
Yes, sir.
The answer is, do they have alpha hydrogen?
Yes, sir.
Yeah, alpha hydrogen is there. So where it is? This, the place where I have put the tick mark. So alpha hydrogens are there. So now you need to don't need any outer molecule, new molecule. Just use this molecule only. Take the CO and take the alpha hydrogen on the other side and combine together, right? So what's going to be the answer?
Is it the first one?
First one. First one cannot be the answer. Actually, overall 10 carbon atoms are there, and the first one is having 11 carbon atoms. Carbon atoms are not going to increase. That also you should know. Yeah. Tell me. So what you are going to do is getting the answer. Look here. So I will put this CHO at the top, right? And this CHO at the bottom. Why? Can you see what I have written? Yeah, Nabil.
Yes, sir.
So what I will do here? Got it?
Yes, sir.
So what's going to be the answer?
Sir, is it three?
Yeah, third one. Correct. Okay. Clear? So this
Yes,
is
sir.
going to be the answer. So this is the way you need to do the aldol condensation. That's it. Actually, there is a ring size which decreases. Because why? Because the ring rejoins again, and it rejoins from new points and the ring size decreases. Okay. That's how you need to know about the aldol condensation. Intramolecular aldol, this is same exactly. Just you need to be bit careful because you are making a ring out of it. That is all. You need to be very careful. Okay. So
Yes, sir.
aldol condensation, crossed aldol, intramolecular aldol, okay, self aldol. So all these are the parts of aldol condensation reaction. Suppose what's going to be the answer? Yeah.
Sir, but no heat, right?
Yeah.
There's no heat, right?
Heat, but benzene is there.
Yes, sir. Sir, how do I name this?
So look for the alpha hydrogen on the other side. This doesn't have any alpha hydrogen. There are alpha hydrogen on this.
Sir, I did that, sir. Like, how do I name this?
How do
I name the product.
product, actually it is aromatic, so it is very difficult to name. There is a special naming for such complex system that is not in the syllabus. Okay. You can tell me what has happened. That's it. They will give you the objective options, right? This one. This is derivative of anthracene. Okay, because three benzene, but anthracene, it's not complete anthracene. You have double bond. Clear?
Yes, sir.
So I hope you are getting this.
Yes, sir.
Okay, very good. So now the next reaction is Kennesaw. So what is Kennesaw reaction?
Sir, in the absence of alpha hydrogen, they'll
I have,
undergo
yeah,
uh, self-oxidation and reduction reaction. It's called as Cannizzaro reaction.
yeah, self oxidation and reduction. So aldehyde which do not possess any alpha hydrogen will give Kennesaw reaction. Okay. Yeah. So for example, the best example is HCHO. So what you are going to get from the formaldehyde? Actually, you need strong base concentrated. Okay.
Yes, sir.
So what you are going to get? Tell me. You have taken one formaldehyde, you have taken.
So we'll get one methanol and one sodium salt.
Yeah. So you are going to change one to acid, carboxylic acid. But the acid is not going to remain acid, change it to salt. And another one to the alcohol. Okay. So similarly, so what's the mechanism of this? Tell me.
So
What is the mechanism of Kennesaw reaction?
the first one hydroxyl group uh, from the base will add a hydroxyl group from the base will add on to the onto one of the aldehyde or ketone groups
Yeah.
and
And
this will remove a water molecule.
no, not water molecule, that will give its edge to another molecule. So this is nucleophilic addition reaction, right? So this edge comes out and is attacked. So there is one molecule on which OH attacks. So the one on which OH attack, the H minus comes out and goes and join itself to another molecule. Okay, this is the difficult step, slowest step, RDS. So what you are going to get? You're going to get double bond OH. And this is CH3 O minus. And this is acid, this is base, so this is going to give H plus. So quick exchange is going to happen, right?
Yes, sir.
And that's how you're going to get the products. One is oxidized, another is reduced. Okay, this is Kennesaw reaction. Suppose if you take two different aldehydes and both of them do not contain any alpha hydrogen, then only Kennesaw. But if any one of them contain alpha hydrogen, then it is not Kennesaw. Is it clear?
Yes, sir. Sir, can you just show the reaction?
Yeah.
Specific.
This step is RDS, hydride transfer. is the slowest step, most difficult. H minus breaks from one molecule and attach itself to another.
Sir, what is the R stand for?
What is
R stand for in hydrogen.
rate determining step?
Yes, sir.
Okay. So slowest step. So this is how the reaction is going to happen. For example, if you take benzaldehyde, what's going to be the answer? Yeah. What are P and Q? And what is going to be R? Yeah, Nabil. Tell me quickly. Nabil, can you hear my voice?
Yes, sir.
What are P and Q?
Sir, benzene, carbox, so, uh, like
Yeah,
sodium
benzene,
benzoic acid, sodium benzoic acid,
sodium
and one
benzoate. Yeah.
phenol. Phenol. I
No,
think
not phenol.
like a benzene with
Yeah,
methanol
benzene
group.
with CH2H.
Yes, sir.
And not going to change the carbon. Right?
Yes,
So,
sir.
and suppose if you take concentrated H2SO4 and heat, then what will happen? Though we have not studied yet, but you must have studied it in the junior classes. Little bit you can think. Conc H2SO4 is used for removal of water.
Yes, sir.
Concentrated H2SO4 is used for the removal of water. It removes water. Right?
Yes, sir.
So tell me what is going to happen.
Sir, we will get like a benzene ring double bonded to a CH2 group.
Hmm. Actually, what is going to happen? This is going to change to carboxylic acid in the presence of H plus. And this is an alcohol. acid and alcohol, if you are going to heat them with H2SO4, the water is going to get removed. Okay. And you are going to get this. So what you are going to get? What will be the structure of R? Yeah. Tell me. Which functional group will it have, Nabil? You must be knowing from your junior classes.
And aldehyde?
No, it will have 2 oxygen. What this functional group is known as?
I don't know, sir.
This is ester. Okay.
Yes, sir.
So what's the characteristics of esters? In alcohol, you must have seen when heated with
So
carboxylic
carboxylic
acid.
acid, acid anhydrides, and acid chloride.
Yeah, acid anhydride, acid chloride, and esters. What is the physical characteristics of ester which make them very famous? We all love esters. Why?
So they have like a fruity smell.
Yeah, fruity smell. Exactly. So esters have fruity smell. That's why. So this is also asked many times. Okay. Clear?
Yes, sir.
So just remember it, because what they do, they give you Kennesaw, they heat it with concentrated H2SO4, and you are going to get your esters, so which are very, very important. Okay, do remember it. Right? So
Yes,
I
sir.
hope this is clear. So let's cover it on the next one. Okay. Next one, Kennesaw, some intramolecular little bit we need to do, and some other reactions, some